Hello, in this video let's discuss fourth question of today's contest. You are given an M2N matrix of positive integers. Return an integer denoting the number of ways to choose exactly one integer from every row such that the GCD of all the chosen integers is 1. Since the answer can be very large, return modulo 1 in n plus 7. The number of rows and the number of columns are up to 150 and the values are also up to 150. So the question is saying that we have M into n matrix, M into n 2D vector, and we have to find the number of ways to select any integer from every row so that ultimately GCD of all these numbers will be equal to 1. For example, let's say we have 2, 2, 1, 3. So for example, if we select 2, if we select 2 and 1, the GCD is 1. If we select this 2 and 3, the GCD is 1. If this 2 1, it is 1. This 2 and 3, it is 1. So total number of ways is 4. Because we can select any 2 from this or we can select any 2 from this, so that ultimately the GCD will be 1. So the answer is 4 in this case. So we have to find the number of ways with GCD 1 like this. So for example, if we are at last row, what is the information that we need to get that the number of ways with GCD 1? For example, if the number is 3, right? For example, this is the last row of the array. If we have something like 3, 4, 5, 6, we have to find the number of ways with GCD 1, right? So if we have 3, what if we have all the primes till now, right? Because the first simple thing that we can think is the GCD should be 1. So if we try to maintain some kind of primes for the way that we got till now. For example, let's say we selected 2 in the first row. So if we selected 2 in the first row and 2 in the second row and 3 in the third row and so on, if we try to select any integer from a single row, if we try to maintain some kind of GCD for that, and then we can try every possibility for the next row, right? And then we can try to maintain some kind of DP, because at every row we have many different choices. We can select any number, so we can try any number from that, right? So we have many choices, so we can try to find the first way, we can try to select the first number, and then we will try to find the answer from the rest of the rows, and then we can try to select the second one, then we can try to find the answer from next rows. So what are the things that we can track to maintain the answer of that type? So we want, firstly, we are at which row, right? We are at which row, and then what is the GCD till now? So what is the GCD till now? So these two are the information that we want primarily. But here the number of ways all are up to 150, right? If they are very small, then we can do some kind of backtracking, because we can traverse all the ways, like all the integers from 0 to n, and then we can try to maintain the net GCD, and then we can go to the next index, and then if the GCD is 1, then we can return 1, else we can return 0. We can do that kind of thing if the conditions are very small, but here they are up to 150. So we have to think slightly more than this. So what we can think, for example, if we are at the last row, if the number is 3, so if the number is 3, we want the number of ways to get GCD 1, right? So what if we have some kind of vector till the above? We are not doing backtracking, but we are simply computing the number of ways to get GCD x till ith row. So what if we have something like the number of ways to get GCD 3 is 5. So what if we have something like this? GCD 4 is equal to 0. GCD 5 is equal to 1. So if we have something like that, then our answer will be very easy, because we have many different choices for the last row also. So we can try all the possible ways. For example, if we select 3, so if we select 3, then what are the, we have to update the vector also, right? Because let's say till the before, this is the last row and this is the last but one row. This is the last row and this is last but one row. For example, the number of ways to get GCD 1 is 2. The number of ways to get GCD 2 is 3. Let's assume these are the constraints, and 3, the GCD is 4. So there are 2 ways to get GCD 1 till now, all the ways, and 3 ways to get GCD 2, 4 ways to get GCD 3. And what if we have something like the number 3 here, 2 here, 4 and 2? So if we have 3, so we have 3, right? So if the GCD till the before operation is 1, till before operation is 1, like before array, before row. For example, if we are at ith row, then the GCD till I minus 1th row is 1. So the number of ways is 1 because we have the number of 1, the number of ways is 2. So the number of ways to get GCD 1 is 2. So if we have something like that, then if we select 3 for the present row, then what will be the new GCD? If we select 1 here, it will be 1 because GCD of this 2 is 1. And we have 2 ways to get GCD 1. So the both ways will be extended, right? So with the both above ways, we can include 3 and we can get GCD as 1, right? Because we have 2 ways, because we have 2 different ways to get GCD 1. And if we include 3 with these both, then we can get new 2 different ways to get GCD 1 ultimately, right? So we got that we have to maintain some kind of vector so that v of I indicates the number of ways from 0th row to ith row with GCD I, right? And now the maximum value in the array is up to 150. So the GCD also can only be up to 150 because the GCD will be obviously less than minimum of those both, and the minimum is obviously less than 150. So the GCD is surely less than 150. So we can try to maintain some kind of vector of size 150. And what is for that? For example, if we are at 0th row, we have to maintain a vector of size 150 so that it have to say that there are x number of ways to get GCD y. So if we try to maintain some kind of vector like that, it will be useful for next row. So let's say after 0th row we have this vector, and then we are going to second row, we are going to first row 0 based indexing, and now we have this value. So if we have this value, then we already have the number of ways to get that GCD. So we can traverse from all the GCD from 1 to 150, and then we can try to utilize the present value. Like we will traverse all these values also, and for a present value for ith index in jth row, so we will try to utilize this value with this number of ways to get the ultimate GCD. So we will simply use GCD of this and GCD of this value, and we will get a new GCD. And what is that new GCD? That new GCD is the number of ways to get till present row, because when we are at ith row, we only have information till I minus 1th row. So when we are going to I plus 1th row, we have to update the information so that we can use for the next indices, next rows. So what we are going simply to do, so at ith row we will traverse all the indices, and then when we are traversing through ith row, we already have vector for GCD till I minus 1th row. And what does that have? For example, let's say this is dp. So dp of 2 is equal to 5. It means that there are 5 ways to get GCD 2. So we have 5 different ways to get GCD 2. And now we will traverse through each and every value of that row, and for a single value we will find GCD of that value and this value, and we will get the new GCD, and we will update that in the new dp vector. So we have these many number of ways. So 5 number of ways will be added to index, which is equal to GCD of present value and then this value. So hope you got this. Let's just check the code. This is very simple. And now we maintain dp vector, dp of size 150. So dp of I indicates the number of ways to get GCD I till that row. And now for the first row, like for the 0th row, we don't have any information. So what can we store? So simply the GCD is the number that we selected. For example, let's say we have 2, 4, 3, 2, 1. Let's say this is the first row. And after this, what will be our GCD look like? Our dp look like? It will be simply there are 2 ways to get GCD 2, because there is only one row. If we select any number, that will be GCD itself, right? So if we select 2, the number of ways is 1 to get 2, and the number of ways is 4 to get GCD 4, and the number of ways is 1 to get GCD 3, and now we got again 2. So what means? It means that we got 2 ways to get GCD 2. This is simply that, and then we got 1 way to select this. So for the first row, the GCD is simply frequency. So for traverse the first row and then make GCD plus plus, because GCD is simply that number. So dp of that number plus plus. If there are 3 numbers with same number, it means that we got 3 different ways to get that GCD itself. And now start through all the rows and then get the new vector, because we have to update this vector for the next row. So this is the new dp vector of size 150, and then we have 1 to 150 different possibilities of GCDs. So simply traverse all the GCDs and if the GCD of that is 0, if dp of x is 0, it means that there are no ways to get the GCD. So why to waste time? So simply skip. So if there are no GCDs, like there are no ways to get GCDX, then simply skip. And now traverse through all the values in the present row. So simply traverse all the values and find the new GCD by using this value. And what will be that value? It will be simply next is equal to GCD of that value and the number which you are at. So simply this, and then update this with new extra ways. So simply dp2 of new is equal to dp2 of that plus dp of x, which is simply the number of ways to get GCD of x till the before row, and then simply mod. And ultimately after this row, so swap dp2 so that dp will be equal to dp2, and now simply return dp of 1 after, which means that the number of ways to get GCD 1. So hope you understand this. If you have any doubts, comment below. See you in the next video.